Food manufacturing sanitation, preventing illness and injury. The importance of good sanitation. Good sanitation prevents foodborne illness. It maintains product quality, which maintains sales, which maintains business. It complies with a host of local, state, federal, and customer requirements. It protects the reputation of your brand. It reduces economic losses because you're not throwing things away, nor are your customers. So let's talk about some key terms when it comes to food plant sanitation. Cleaning. Cleaning is the physical removal of debris and contaminants from food contact surfaces and from nearby areas that could potentially contaminate nearby food contact surfaces. Sanitizing. Sanitizing is the next step after cleaning, and it is the process of reducing the microorganism count on the cleaned surfaces to a safe level. You cannot sanitize a dirty surface, so this step must follow the cleaning step. Cleaning comes first. Disinfecting. Disinfecting is the process where virtually all microorganisms are eliminated. It is a higher standard, using more effective materials, and is generally reserved for specific areas of certain facilities. Hygiene. Hygiene refers to the conditions and practices that help maintain sanitary conditions and prevent the spread of microorganisms. Hygiene is the base, the underlying proactive steps that everyone follows for their personal cleanliness and the cleanliness of their work areas. Now, in terms of contamination, there are three main types of contamination. We'll use HACCP principles, and using those principles, here are the three main types. Biological, meaning pathogens. Chemical, meaning substances that do not belong in the product and are potentially harmful. Physical, meaning objects that do not belong in the product and are potentially harmful. Now, where do these contaminants come from? There are four main sources of contamination, so you want to keep a close watch and tight programs over the following. Raw materials coming into your facility or currently in storage. Surfaces, especially flat surfaces that gather dust, dirt, and contaminants. People, arguably the greatest single source. And lastly, the environment surrounding your food areas. Remember this, it is much more difficult to clean and sanitize a dirty area. So don't make things worse than they need to be. This ties back again to hygiene and good practices. In terms of hygiene, personal hygiene in food manufacturing is key. Nothing will have a greater impact on your facility's sanitation as your employees' personal practices. Here are some examples. Hand washing, gloves, hair coverings, GMP compliance, health and illness policies and practices, clean clothes devoid of contamination. Cleaning and sanitizing work together. Establish sanitation standard operating procedures. Have detailed instruction manuals. Those are SSOPs. Determine the optimum cleaning frequencies. Operational needs must not provide food safety risks. Use the correct cleaning agents. Here are some ideas for you and some information. Alkaline cleaners are used for grease and oils and fats and proteins. Acid cleaners are used for rust, mineral deposits, scale, calcium. Detergents are for neutral cleaning of walls and general area, including some food contact surfaces depending on the contamination. Enzymatic cleaners are used for some types of organic material. Sanitizing. Sanitizing is the reduction of microorganisms to a safe level, as mentioned earlier. Here are some examples of sanitizers. chlorine-based sanitizers are the most popular because they are inexpensive and they work well. However, surfaces must be very clean for best effect. Organic material minimizes the effect of chlorine. Quaternary ammonium compounds are also very effective and can have some residual antimicrobial effect. Peroxyacetic acid works well and is effective even in the presence of small amounts of organic material. Iodophores are very effective. These are iodine compounds, but they can have some staining issues, as you could probably guess, and they work best in mildly acidic form. Lastly, alcohol-based sanitizers. They work very well, but they evaporate quickly and, of course, can be dangerous to handle as they are flammable. Cleaning methods. Dry processes should always be dry cleaned. Sweeping, blowing, wiping, and vacuuming are the most common methods used. Remember that compressed air blowing must use clean or instrument air if blowing on food contact surfaces, and anything relocated by compressed air must still be gathered up and removed in some fashion. So compressed air has its pros and cons. Merely relocating material via compressed air is not the same as cleaning. Wet processes should always be wet cleaned. Mixed processes consisting of both wet and dry operations must be given careful consideration in developing their SSOPs. Wet cleaning on dry processing is the biggest risk. Let's talk about sanitary design. If machinery or a plant area cannot be cleaned well, it won't be. Machinery design, plant layout, working space, access, and proper cleaning tools and chemicals all must work together. Always look under. Look underneath as many places as you can. Out of sight can be a recipe for disaster when it comes to cleaning and sanitation. How about monitoring and verification activities? Well, records must be kept of all sanitation activities. You need to assure yourself and your customers and any regulatory agencies that you are following your program. If you didn't write it down, you didn't do it. You must determine the effectiveness of your program. This is accomplished in several ways. The most basic, most frequently used method is a visual inspection after cleaning. It should be performed by a competent person who is not part of the sanitation effort. That is because they must be competent and unbiased. The results of the inspection must be documented. There are telltale products available that can detect microscopic contaminants invisible to the naked eye. Some examples. ATP bioluminescence testing can detect residual organic material and possible microbial contamination. The results are rapid and they can indicate that a surface is not sufficiently cleaned before you apply a sanitizing agent. Sample swabbing and microbial testing are not immediate as they take 1 to 2 days for results, but they do provide verification that your program is working as intended, or not. Protein residue testing is like ATP testing as it indicates inadequate cleaning due to the presence of stray protein. Lastly, allergen testing. It's crucial for facilities that require allergen cleaning. There are specific products to detect specific allergens to ensure that you have a proper cleaning. So in conclusion, good manufacturing practice requires that you maintain a sanitary environment free from the threat of manufacturing adulterated products. Your programs and people ensure this. So create good programs, strive to constantly improve, and provide excellent training to your people. Always keep your facility as clean as possible. That is in order to minimize the possibility of your sanitation program proving inadequate. Never forget, you aren't just making any old product. You're making someone else's food.